Alright, this is the introductory lesson for O-Chem nomenclature. You should all have these notes for the next 2 pages, but if you do not take this opportunity to write them down, you can pause this video and re-watch it at any point in time. So be sure you're doing that if it goes. So the recording paused on me. Don't remember exactly how far I got, but these are the notes that you'll need. You should already have these. If you do not, get them down now. You can pause the video at any time. Next, we have number of bonds. Single bond is "-ane", double bond has the suffix "-ine", triple bond has the suffix "-ine", and all the prefixes 1 through 10 are written there. You should have these notes, but if you don't, take a moment to write them down now. Okay, new notes. Steps for naming molecules. Remember, you can pause this video and rewind at any point in time. Steps for naming molecules look like this. Step 1, you have to locate the longest chain of carbons. Step 2, you have to determine whether there are single, double, or triple bonds. For our intents and purposes today, there will only be single bonds. So we will be working only with molecules that end in "-ane", because single bonds always end in "-ane". To finish the notes, you'll have to number the chain starting at the end nearest a single bond, and you'll have to note where any multiple bonds are located or branched molecules. And so we're going to work 3 example problems right now. Remember, you can pause at any time. Example problem number 1. I have a chain of 4 carbons in a row. If I look, I'm going to write all examples. Example 2, I have this chain. Example 3, I have this chain. Alright, for example number 1, I have 4 carbons all in a row. If I look back at my notes, I check and see, oh, 4 carbons in a row, that's the prefix bute. So now I move back to my chain, and I number them 1, 2, 3, 4. I decided that 4 equals bute. I note that they are all single bonds, just one line. Here's an example of what it would look like. A single bond has one line, and its last name is "-ane". A double bond has 2 lines, and it ends in "-ine". A triple bond has 3 lines, and it ends in "-ine". So this is butane. Bute for the 4 carbons in a chain, "-ane" for the single bond. Remember to re-watch this as many times as you need. Number 2, I'm going to number my carbon chain. 1, 2, 3, 4, 5, 6, 7. All of those carbons are all linked together. You could draw through them without picking up your pencil or going backward. So that is how you define a chain. 7 from my notes is hept, and they are all single bonds, so it is hept-ane. Final answer. This next one is tricky because there's a branch. The longest chain you might think is 1, 2, 3, 4, 5. That is not actually the case with this compound. You could number this, remember that 5 is pent, but that's incorrect. You could number this 1, 2, 3, 4, 5, 6. 6 is now the longest chain. It does not have to be in a straight line. Just like this was not in a straight line and was a complete chain, this is not in a straight line but is a complete chain. You could number this another way too. Remember, 6 is hex. You could number it 1, 2, 3, 4, 5, 6. So again, that 6 would be hex. Those are the longest chains I can find, so I'm going to call this a hex. If I had found 7 carbons in a row, I would have called it a hept, because 7 is hept. So it's hex and it's "-ane because there are only single bonds. I didn't draw arrows because it would just be too much stuff, but you can see they're all just single lines. On your homework, you'll see hydrogens attached to these carbons. So there's my longest chain, or there's my longest chain. It doesn't actually matter which you picked. So now, on your homework, you'll see hydrogens attached to these carbons, and I'll show you what that looks like. Remember, from our notes, carbon can make 4 bonds because of its 4 valence electrons. Hydrogens are used to get to 4, and I'll show you what that means. Here's an example. Okay, this is a chain of 4 carbons. The reason I know it's 4 carbons is because it's 1, 2, 3, and I could either go up to 4, or I could go 1, 2, 3, down to 4. So it's a butte, but we won't worry about that. If you'll note, this carbon has 1 bond attached to it, but carbon wants 4 bonds. So what we need to do is add 3 hydrogens. Now this carbon has 1, 2, 3, 4 bonds attached to it, so it's happy. This carbon has 1 bond, 2 bonds attached to it, so we need to add 2 hydrogens, so that it now has 1, 2, 3, 4. So that's 1, 2, 3, 4, and it's happy. Lastly, I guess we have a couple more. We can look at that carbon up top. That carbon up top had only 1 carbon bond, so we added the 2, 3, 4. This carbon has 1, 2, 3 bonds, so we just need to add 1 hydrogen to it. This carbon has only 1 bond, so we need to add 1, 2, 3 hydrogens to it. Sorry that ended up on the watermark. But you get the idea, and that is how you solve these problems. This molecule right here will be written on your homework like this, CH3, because the first carbon has 1, 2, 3 H's. The second carbon has 1, 2 H's, so it'll be CH2. This third carbon has 1 H, so it'll be CH. It goes up to a carbon that has 3 hydrogens and down to a carbon that has 3 hydrogens. So this carbon is represented here, and this carbon is represented here. That's how you'll see it on the homework, but you'll solve the problems the exact same way as we did. So what you'll do is you'll say, well, this looks like my longest carbon chain. 1, 2, 3. You could either put 4 here or 4 here. It doesn't matter. The longest chain is just going to be 4 carbons. So then you would call this a butane, like our first example problem, ignoring this branch for the time being. I just want you to circle the longest chain and write whether it is a butane, pentane, ethane, whatever, 1 through 10. Those are the notes for today. You should have the worksheet in front of you. If you do not, they are up front. What I want you to do on the worksheet is write the branch name or the chain name as far to the right as possible, and an example of that is on the board. Good luck. See you guys tomorrow.